Okay, my name is Ryan Vaught. I was in the ECT295L course. This is actually take two. I just did my entire presentation and realized that the video was not recording the whole time. Apologize beforehand. I have my 9-month-old daughter tonight watching her, so you may hear her talking or jumping in her bouncer. But so my project was the overdrive pedal. It's the same. I know I said distortion pedal, but they're the same kind of pedal. The difference, a distortion pedal distorts no matter the volume level, it just distorts the sound regardless of what's coming out of the guitar. The overdrive pedal increases the distortion as the gain increases. So when you reduce the gain, you get a clean tone, so you can get a larger range of distortion. You can, instead of just one level of distortion, you can actually get a range of it. My objectives were to choose a schematic for the overdrive pedal, build a bill of materials for the parts needed based off the schematic, build a prototype, test functionality, troubleshoot as needed, build a final assembly that is functional and meets all requirements of an overdrive pedal. Milestones were project selection, schematic selection, bill of material creation. Then the next one was simulation, parts ordering and gathering. Then the week 3 milestone I had was a fully functioning prototype. My week 4 was the final assembly to be completed. Functioning, week 5 was the report, and 6/7 was to finish the presentation. I was on target with every one of these. I got them completed by the dates that I had set. I only ran into a couple minor issues in my initial prototype getting work, but it took me 20 minutes, 30 minutes of troubleshooting, and I had that figured out. The overdrive pedal description, there's 3 basic pieces of equipment used for playing an electric guitar. Obviously you gotta have your electric guitar, and then you have an amplifier, which is what the speaker is in. That's what produces all the sound after it's been altered, or even after it's not been altered. The effects pedal is what alters the sound coming from the guitar. What is an overdrive pedal? It adds a slight distortion effect to the sound. And by slight, I mean most distortion pedals will get a heavier distortion, like a lot more distortion out of it. The reason, well, the overdrive pedal, it amplifies the sound by boosting the gain. So like I said earlier, a distortion pedal just straight up distorts the sound at a certain level. It's a set gain, whereas this has a range of from being clean tone all the way up to distorted. So you can get a range of somewhere in between or at either extreme. These are examples of 3 pedals that you can buy online or at a guitar store. You have a Behringer overdrive pedal, a Boss over here. I'm not sure of the actual brand on this one, but I use these 3 examples to show they always have the same, they typically have the same setup. 3 knobs, you have a volume, a tone, and a gain, or they call it level and drive instead of volume and gain. I actually used to have this pedal right here. The reason why I chose this project is because when I had that pedal, it wasn't working very well for me. I had issues with it. So instead of buying a new one, I thought I would try to build my own, and that was 15 years ago when I first started studying electronics. I didn't succeed in doing so, and so I thought, well, that might be something to revisit and try now, since I've got 15 years of working with electronics and working as an electrician. The basic functionality of the pedal is the audio is input from the guitar straight to the overdrive pedal. So the guitar plugs into the pedal. That signal from the guitar is generated from the pickups, which you'll see in my video are behind the strings on the right hand. It's a series of magnets. Most guitars you can see each little magnet, and many of you have probably seen them. Mine are a little different. They're called EMG Hertz pickups, and they just look like a plastic box. But under that plastic box are those magnets that you see on most other guitars. Those magnets transform the vibration of the string into an audio signal, a sinusoidal, I have trouble saying that one, but a sine wave signal, analog. The audio signal goes through the amplifier circuit of the pedal to the output. The amplifier circuit, there's 3 controls: the volume, tone, and the gain. The volume increases the volume, the tone changes the sound of it, whether it's like a darker or a brighter tone, and the gain is what boosts the sound even more and adds the distortion to it. Audio signal leaves the output of the pedal and goes directly to the amplifier, which is where your speaker is. This is the schematic I chose. You have your audio input, your audio out, about 7 or 8 resistors, my 3 potentiometers and my knobs, the gain, tone, and the volume. Some caps and a couple LEDs and diodes, and then a 2N3904 transistor. This was the bill of materials that I had developed. I was going to order everything through DigiKey. I had set a budget of $40, and from DigiKey my order was going to be $25.37. And what actually ended up happening was every one of these components here, except for these last 2, I had and my kids from previous classes, so I did not have to order any of those. And then the input and output jacks for the guitar, I still had those from when I tried this project 15 years ago. So, and then a 9-volt battery I had here in the house. So I actually didn't have to buy anything for this project. Even the PCB, I already had that. So in the end, it didn't cost me anything. If you look at long term, and when I bought those, yeah, it did cost me a little bit. I think I paid $3 or $4 a piece for those input and audio output jacks 15 years ago. And actually they actually came off of the original pedal that I had, so they didn't cost me anything. As even then, that pedal I bought used for like $20. So this was my prototype. This was the original non-working prototype. I had it kind of cramped down into one small area. I didn't use the 4 power, whatever you want to call them, lug nut things at the top, the VA, VB, and VC as actual power delivery. Those are my audio input and output wires going out to the jacks. I just used them as anchors because I kept accidentally pulling the wires out of the breadboard when I was trying to plug the guitar into the audio input and outputs. Going back to that, the only troubleshooting that I had to do was, well, I didn't have any sound coming out. And so what I ended up doing, I actually rebuilt this and kind of expanded it out. And when I did that, I found that I had the transistor plugged in backwards. So anything that was going to pin 1 was supposed to go to pin 1 actually went to pin 3, and vice versa. But once I flipped that transistor, everything worked perfectly. For initial testing, I used a function generator to simulate the input from the guitar. I found that most guitars output somewhere around 100 millivolts signal. It depends on the guitar, the style of pickup, which pickups you're using, the one that's closer to the fretboard or the one that's furthest away from the fretboard, which is the neck that you play with your left hand, or right-handed if you're a left-handed guitarist. I chose a frequency of 200 hertz. From my music knowledge, I was big in music in high school. I knew 440 hertz was an A. That's kind of high for a guitar. And then I verified and looked up online that 200 hertz is a signal within the range, about the middle range of the guitar. I used an oscilloscope to capture the input and the output signals and took measurements with the gain, volume, and the tone knobs in different positions. These were my 4 oscilloscope images. Channel 1 is the yellow, and channel 2 is the blue. The yellow channel 1 was my input from the guitar, and channel 2 is the output from the pedal. So you can see here on this first one, I had the volume knob all the way down, so I had no output. This is with the gain knob and the tone knobs turned up, and it distorts the sound and changes the tone of it. This is with the tone and volume all the way up, but the gain all the way down, so I had a clean tone that matched the input. And this was with the gain turned down slightly and the tone turned down slightly. So you can see the differences between no volume, 100% volume, and gain, no gain and a little bit of gain, and then your tone, changing the signal a little bit too. This was the final build. I chose the PCB, generic PCB to build it. It was a lot easier. I would have liked to have done an actual design PCB for it, but I just did not have the time to do that. There's my audio input, audio out, and there's where the 9-volt battery plugs into my 3 controls. The lessons I learned from this was the process of project selection, design, testing, and implementation. I just learned how to use a function generator better because I wasn't being told by a professor or a class instruction on what signals to use and what to set it at. Having to learn to find that myself. And then finally I learned the basic functionality of guitar effects pedals. I had a general idea, but I learned a lot more how the amplifier circuit works and how the controls play into the circuit. Finally, here's my video, and I will go ahead and start that. That's the demonstration. And there we go. Hello, my name is Vaught. Here for the ECT295L online course for my final course project. For my project, I chose to do a distortion pedal for an electric guitar. So I have one that I own right here, the Ibanez RG350 series. I chose to do a distortion pedal. What I ended up building was actually called an overdrive pedal, which is a distortion pedal. The standard distortion pedal provides the same level of distortion no matter what volume the guitar and the pedal are at. The overdrive more or less distorts it by increasing the volume and the gain on the signal coming from the guitar. So my original plan was to actually put this board on a PCB that was designed specifically for this, but what I ended up building was I ended up just doing it on a generic board. On the bottom side I just soldered all the connections. I also wanted to get an enclosure. I didn't get to that. There was just not enough time to do that. But what I have here does work. It's solid. I could, mount the audio cables onto this board. What I'll be playing it through is my Behringer amp here. Now this amp does have effects built into it, but for the purpose of this project I do have it on a clean tone. So it is like a straight through, just clean sound of the guitar. So right now I'm not plugged into the pedal, but I will demonstrate here in a minute and plug it into the pedal to show what kind of difference it makes. So this is kind of the sound that you get with just a clean tone. Hopefully, sorry about the shaking here, I got a little stand I'm trying to get set up. So this is what it sounds like clean just through the amp with no effects. It's just a real clean, there's no distortion, no kind of reverb or anything else. The idea there. What I will do now is I will actually disconnect this from the amp, the guitar from the amp, and plug in the guitar, the distortion pedal. I have to get a second cord here because I'll have one going from the guitar to the pedal and then one from the pedal to the amp. So we end up with something like this right here. So I've got my input right here. That's coming from my guitar. And then the output over here, which goes directly to the amp. I also have a 9-volt battery I have to plug in. Without that, there's no sound whatsoever coming from the amp. Once I plug that in, you will start to hear what this thing sounds like. And I'll demonstrate the knobs and controls on it here in a minute. Once I get it. Try to get this anchor down a little better. Kind of towards pulling the pedal off of the table. Just leave that there. I was going to clamp it down, but it doesn't appear like it's going to work. So now the battery is plugged in, and you can clearly hear the difference already. So I've got 3 controls on here. A volume control, which is this one right here,